Hello students, in this lecture we will discuss about the effect of electric current. Three important effects of electric current are there. These are heating effect of electric current, magnetic effect of electric current and chemical effect of electric current. When current passes through the conductor gets heated. That's the heating effect of electric current. When the current passes through the conductor behaves like a magnet. It generates the magnetic behavior. That's the magnetic effect. And chemical effect, when the current passes through the current can bring about number of chemical changes in conductor. That's the chemical effect. So in this chapter we will discuss about the heating effect of electric current. Next chapter we will discuss about the magnetic effect. Chemical effect we will not discuss here. This is not in our syllabus, so this is not of our concern. So heating effect, let's understand students. When current passes through the conductor, because of the presence of resistance, the conductor gets heated. What is the reason? When the current passes through the conductor gets heated. The reason is the resistance. The more is the resistance, the more the heat will be generated. Lesser is the resistance, less the heat will be generated when the current passes through the conductor. These are some of the devices that works on this principle, heating effect of electric current. That's what electric heater, electric toaster, electric bulb, electric fuse are the device which is based on the heating effect of electric current, and many more such devices are there which works on this heating effect of electric current. Magnetic effect, when current passes through the conductor, it exhibits the magnetic character. Means when the current passes through the conductor, it behaves like a magnet. It produces the magnetic behavior around it. That's the magnetic effect. There are some of the important devices which works on this magnetic effect of electric current, students. These are electric motor, electric generator, and many more such devices are there which works on this principle. That's the magnetic effect of electric current. We will discuss more about this in the next chapter. So chemical effect, let me just briefly tell you what is the importance of this chemical effect. When the current passes through the conductor, it can bring about number of chemical changes. We use this effect in industries for the electroplating or the electrolysis. When current is passed through the water, the current decomposes the water into hydrogen and oxygen. That's the important and simplest example to understand the chemical effect of electric current. Okay, students, let's move on and discuss the laws in electricity. We have two important laws in electricity. The first one is the Ohm's law and the second one is the Joule's law. Student, Ohm's law tells us about the relation between V and I. That's the potential difference and the current. Suppose this is the conductor. If we maintain a potential difference of a V volt across the end of this conductor, the current flows. And it is found experimentally, if you maintain the more potential difference across the end of this conductor, the more current flows through the conductor. And suppose if we decrease the potential difference across the end of the conductor, the current flowing through the conductor will also be less. So it has been found experimentally that potential difference across the end of the conductor is directly proportional to the current. Means increase the potential difference across the end of the conductor, the current flowing through the conductor will increase. Decrease the potential difference across the end of the conductor, the current flowing through the conductor will also decrease. So this is the relation between the potential difference. Or we can say Ohm's law states the relationship between potential difference and the current. Students, let's briefly discuss what is Joule's law. Joule's law of heating effect. As I mentioned, when the current flows through the conductor, it generates heat. So Joule's law tells us about the relation between the amount of heat generated, the current flowing through the conductor, the resistance, and the time taken. Okay, students, let's discuss Ohm's law in little bit detail. Let's understand the definition first. What does Ohm's law says? The current flowing through the conductor is directly proportional to the potential difference applied across it, provided the temperature remains constant. Current flowing through the conductor is directly proportional to the potential difference applied across it, provided the temperature remains the constant. Suppose I have a conductor here. The two end of the conductor is connected to the two terminal of a battery or the cell. So we have maintained a potential difference of a V volt across the end of the conductor. Now students, the current will flow, and students, this arrow indicates the direction of the conventional current, and we know no such current exists in reality. Electrons will flow in this direction. This is the actual flow of the current. So if we maintain the potential difference across the end of the conductor, the current flows through the conductor. If we increase the potential difference, if we increase the battery's voltage potential difference, the current flowing through this conductor also increases. If we decrease the potential difference across the end of the conductor, by decreasing the potential difference, by decreasing the voltage of this battery, the current flowing through the conductor also decreases. Experimentally, it is found that if you increase the potential difference, if you increase the battery voltage, means increasing the potential difference across the end of the conductor, the current flowing through the conductor is also found to be proportional. Increase the potential difference, current flow will increase. Decrease the potential difference, current flow will decrease. That's what the Ohm's law says. Now, mathematically, V is proportional to I. V is equal to Ri. Students, here R is the resistance of the conductor. We discussed in detail about the resistance of the conductor. Resistance is the inherent property of the conductor. Because of this property, the current gets the opposition when the current flows to the conductor, or because of this property, the conductor gets heated. More is the resistance, more heat will be produced. Lesser is the resistance, less heat will be produced. Now, students, let's see VI graph. If we plot the graph between V and I from this equation, let's say suppose we plot the potential difference across the along the vertical axis and current along the horizontal axis. We get a graph straight line. We get a straight line graph passing through the origin. That's the VI graph. Now, slope of this graph indicates the resistance. Students, remember, slope of the VI graph gives us the resistance. Very important conclusion. Now, what is the importance of this VI graph? Let's see. Suppose if I draw the two VI graph for the conductor A and B. Suppose we have drawn the VI graph for the two conductor A and B. So from this graph, we can see the slope of a graph A is more than the slope of a graph B. So the graph or the conductor which have a higher slope will have a higher resistance. RA is greater than RB. The conductor with higher resistance or the conductor with a higher slope will have higher resistance, and the conductor with a low slope or a smaller slope will have a less resistance. So from this graph, we get the idea of high resistance and low resistance. That's the importance of this graph. Now, students, we also discuss about the units of resistance. SI unit of resistance is the ohms. This is the symbol of our ohms that we have discussed. Circuit symbol. Now, while drawing the circuit diagram, we need to show the resistance, and this is the symbol, circuit symbol, that we will be using to represent the resistance in the circuit. Now, students, let's discuss what is 1 ohm resistance. From this mathematical equation, R is equal to VI. If I want to define 1 ohms, I'll write 1 ohm in place of this R, and this V potential difference, I'll write 1 V, and this 1 ampere. Current, in place of a current, I'll write 1 ampere. So 1 ohm can also be expressed as 1 volt per ampere. Now let's understand, student, what is 1 ohm resistance. 1 ohm resistance is defined as the amount of resistance offered to the current when 1 ampere current flows through the conductor on applying a potential difference of 1 volt. Now let's understand, students. Suppose I have a conductor. I have maintained a potential difference of 1 volt across the end of this conductor. And you know, students, when there is a potential difference across the end of the conductor, the current flows. So say suppose on maintaining a potential difference of 1 volt across the end of this conductor, say current flowing through the conductor is 1 ampere. So on maintaining a potential difference of 1 volt across the end of the conductor, if the current flowing through the conductor is 1 ohms, we say the resistance offered by this conductor to the current is 1 ohm. Again, students, if I maintain a potential difference of 1 volt across the end of this conductor, if the current flowing through the conductor is 1 ampere, the resistance offered by this conductor is said to be of 1 ohm. That's how we define 1 ohm resistance. I hope, students, you understood it. Now let's understand the next law, that's a Joules law of heating effect. Now, students, Joules law tells us about the amount of heat generated, the relation between the amount of heat generated, the current flowing through the conductor, the resistance of the conductor, and the time for which the current flows to the conductor. Here is the relation. Let's understand the definition first, the statement first. Joules law of heating states that the amount of heat generated when current flows to the resistor is directly proportional to square of the current, resistance of the resistor, and time for which the current flows. Say, student, I have a conductor. The resistance of this conductor is R. If I maintain the end of this conductor at a potential difference of, let's say, suppose V volt, and because of this, current flowing through this conductor is I ampere. If I allow this current I to flow through this conductor for T time, Because the conductor have a resistance, heat will be generated. So how much is this heat generated? Joule's law says the heat generated is directly proportional to square of the current. Directly proportional to square of the current. Directly proportional to square of the current. Heat generated is directly proportional to square of the current. Heat generated is directly proportional to the resistance, and heat generated is directly proportional to time. Means if you allow the more current to flow through this conductor, the amount of heat generated will be higher. If you increase the resistance of this conductor, the heat generated will be higher. If you allow the current to flow through this conductor for longer period of a time, the heat generated will be higher. So if we combine all this factor, mathematically we get the equation like this: H is equal to I square RT. Increase the current flowing through the conductor, heat will increase. Increase the resistance of the conductor, heat produced will be higher. Increase the time duration for the current to flow, heat production will be higher. And if you decrease all these three quantities, decrease the current, heat production will be less. Decrease the resistance of the conductor, heat production will be less. Decrease the time duration, heat production will be less. So this is what the Joule's law of heating effect says. And these are some of the devices which works on this heating effect of electric current. Electric bulb and electric fuse are two important devices which works on this principle. That's the Joule's law of heating effect. Okay, students. With these two laws, we end today's lecture. Students, the next lecture we will discuss about the connection types, that is resistors in series and resistors in parallel, and we'll discuss some of the numerical problems based on the type of connections. So for today, that's all. Thank you. Students, now let's continue with our next part of this lecture series. That's the connection types, the type of connections in electricity. Students, we have two different type of connections in electricity. It's a series connection and a parallel connections. Let's understand what is series connections and what is parallel connections. Let's try and differentiate this. Students, we know how do we represent the resistance. We have a circuit symbol of a resistance like this. These are the resistors. Suppose I have three resistors, R1, R2, R3. We can take any number of resistors, but for simplicity, let's take three resistors. Resistance R1, R2, R3. We have three resistors of a different value, R1, R2, and R3. When we connect these three resistors in series, when do we say these resistors are connected in series? If one end of the resistor is connected to the another end, and the another end of the resistance 2 is connected to the first end of the resistance 3. If we connect all these resistors end to end, the end-to-end connection of resistors are said to be series connections. So this is the series connections. And now one end of this first resistors and the another end of this last resistors, if they're connected to battery. And if I plug the key, the current flows. Now student, you know this direction. This is the conventional current's direction. Conventional current always start from the battery's positive terminal. So the current flows like this and it ends at the negative terminal of the cell. Now student, when we connect all the resistors in series, the amount of current released by the battery, the same amount of current passes through all the resistors. Same amount of current passes through all the resistors. That's what we mean by this line here. The second statement, same current flows. Same current flows means I amount of current is released by the battery. The I amount of current is flowing through the resistance 1. The same I amount of current is flowing through the resistance 2, and the same I amount of current is flowing through the resistance 3. That's what we mean by same amount of current flows. And student, that this point is very, very important. This point will help us identify how the resistors are connected. Resistors are connected in series or in parallel. Sometimes in complex series, complex circuits, we have to identify the resistors are connected in series or in parallel. The only way to identify the resistors connected in series or parallel is to check the same amount of current is flowing through all the resistors or not. So this is how we connect the resistors in series, students. The end-to-end connection of all the resistors in series, end-to-end connection of all the resistors are called series connections. Now student, if we have the same three resistors, if I want to connect all these resistors in parallel, then what's the way? Student, see, we have resistor 1, this is resistor 2, and this is resistor 3. This is the one end, this is the one end, the first end of all these resistors. There's another end of this all these resistors. Student, if I connect all these ends, the first end of all the three resistors to one common point, and the another end of all these resistors to another common point, such type of connections is said to be parallel connections. What happened in case of a series connection? Say suppose I have resistors 1, resistor 2, and suppose resistor 3. So here one point, this 2 point is connected, and this point is connected to this point. So such type of connection was called a series connection. But what happened here? In these three resistors, all this common point, the first point of every resistor is connected to one common point, and the second point of every resistor is connected to second common point. So such type of connections are said to be parallel connections. Now student, if this common point is connected to battery's positive terminal and this another common point is connected to battery's negative terminal, and if we plug the key, what happens? The current flows. The conventional current starts from the battery's positive terminal, and the moment the current reaches to this point, now the current has a three different paths to go, three different paths to follow. Now the current gets divided. Let's say I1 current flows through the resistance R1, I2 current flows through the resistance R2, and I3 current flows through the resistance R3. Now three different branches are there. The current has an option to go through all these three different branches. So current I gets divided into three parts, I1, I2 and I3. I1 flows through R1, I2 flows through R2, and I3 flows through R3. And at this point, again this three current I1, I2, I3 combines to give us the same current I, and it flows back to the negative terminal of the battery. Now student, just compare the series and parallel connections. What happened here? The battery released the current I. The current I is flowing through R1. The same current I is flowing through R2. The same current I is flowing through R3. But in case of a parallel connections, what happened? The battery released current I, and at this point, the current got divided into three different arms, I1, I2, I3. That's what we mean by this line. Different current flows through the different resistors. Now through this resistor R1, I1 current is flowing. Through the resistors, I2 current is flowing. Through this resistors, I3 current is flowing. That's what we mean by different current flowing through the different resistors. Okay student, now let's move on to third point. In series circuit, series connections, different potential difference across every resistors will be different. Let's say this is one end, this is another end of the first resistor. So there is a potential difference across the end of this resistor. So let's say suppose this is V1. Now this is the one end of resistor R2, and this is another end of the resistor R2. Across this two end also there is a potential difference. Let's say it's V2. And this is one end of the resistor R3, and there's another end of the resistor R3. Across this end also there is a potential difference V3. Student, series connections, the resistors, they shares the voltage among themselves. The voltage among themselves, that's the battery voltage. This is the battery voltage V. So all these resistors, they are connected in series. They will share the battery voltage. Sharing battery voltage means V1 plus V2 plus V3. If I add all these three voltage, we'll get the battery voltage. That's what we mean by different potential difference. Student, remember, when the resistors are connected in parallel, series, the resistor shares the battery voltage. Like R1 is getting V1, R2 V2, and R3 V3 potential difference. Here in case of this parallel connections, all the resistors will get the same potential difference as that of the battery. Now here battery voltage is V, so this resistor also gets V, this resistor also gets V, and this resistor also gets the voltage V. So here the potential difference remains same. When the resistors are connected in parallel, so all of them gets the same potential difference. That's what we mean by this line, same potential difference. Now student, next point. The net resistance of this series circuit is calculated by this formula. Sum of the net resistance, this R is the net resistance. Net resistance is calculated as a sum of the individual resistance, R1 plus R2 plus R3. And here in this case, the net resistance is calculated as the sum of the reciprocal of the individual resistance, 1 by R1 plus 1 by R2 plus 1 by R3. Now student, what is net resistance means? Student, suppose if I want to replace these three resistors by one single resistance, I want to know what should be the value of that single resistance. So that's what we mean by the net resistance. If I want to replace this 3 resistance by one equivalent resistance, then we will be calculating the net resistance by this formula. Similarly, if I want to replace this 3 resistors by one single value, one single resistance, then that value of that single resistance can be calculated by this formula. Student, the net resistance in this circuit increases. Now, what does it mean? Net resistance increases means, say suppose I have resistance R1 as a 2 ohms, resistance R2 as a 3 ohms, and resistance R4 as a 5 ohms. If I want to replace all these resistors by a single resistance, then the resistance is calculated as the sum of the individual resistance, that's a 2 plus 3 plus 5. So we'll get the total 10 ohms resistance. Now students, see, the net resistance has become 10. So that's what we mean by this line, net resistance increases. Now this net resistance has increased. The net resistance has become greater than the greatest of all these values. See, among these 3 resistance, we have the greatest value 5, but our net resistance is greater than the greatest of all these 3. That's what we mean by net resistance increases. Now student, the same here, net resistance decreases. Say suppose I have 3 resistors of value, let's say suppose 2 ohms, and say suppose 3 ohms, and let's take 4 ohms. If I want to connect all these resistors if I parallelly, so what is the net resistance if they are connected in parallel? 1 by R1 plus 1 by R2 plus 1 by R3. Let's say 1 by 2 plus 1 by 3 plus 1 by 4. Now simplify this. What will be the LCM? 12. So 6 plus 4 plus 3. 13 by 12. So 1 by R. If you simplify this, you'll get the value 12 by 13. Now student, this value is smaller than 1. Student, these 3 resistors, the smallest of all these 3 resistors is 2. But when we connect them in parallel, our net resistance decreases. Net resistance decreases. You see, the net resistance has become smaller than 1. Our net resistance has become smaller than the smallest of all these 3. So this is the meaning of this line, that net resistance decreases. Now student, where do we use this series connections and parallel connections? Series connections we use for the decoration purpose, decorating lamps, especially in functions, special occasions. The lights are decorated. The decoration lamps, the decoration light makes use of the series connection, students. Now domestic purpose, parallel connections is used in our home, our factories, schools, hospitals, office. So domestic purpose. Now next point, student, it's a ammeter. About the ammeter and voltmeter. Student, ammeter is connected in series. Ammeter is a device that measures the current, and voltmeter is a device that measures the potential difference. Now ammeter is connected in series and voltmeter is connected in parallel. Now let's understand how do we connect this ammeter and voltmeter in series and parallel. Students, say suppose I have a circuit here. Let's say this is the circuit. The current flows through this circuit. There is a certain amount of current flowing through this resistors. I want to know how much is the current flowing through this resistors. Now to know how much of a current is flowing through this resistors, I have to connect ammeter, because ammeter will tell us how much current is flowing in this circuit. Now to connect this ammeter, as I mentioned here, ammeter should be connected in series. So where should I place that ammeter? I can place anywhere in this circuit. But care must be taken. Let's say suppose I'll place the ammeter here. Ammeter here. But when we place the ammeter, we must make sure that negative terminal and the positive terminals are connected properly. Now what does it mean? It means now if I place the ammeter here, the negative terminal of this ammeter should be connected to negative terminal of the battery, and the positive terminal should be connected to the positive terminal of the battery. So this is the series connection. How do you know this is series connection? Students, see, pay attention to this point. Same current flows. The battery has released certain current. The current which is flowing through this resistor, the same amount of current is flowing through this ammeter. That means ammeter is in series. So this is how we connect the ammeter. Now next, see voltmeter. Students, say suppose I have a resistor here. A battery is connected and the current is flowing. Current is flowing through this resistor. I want to know how much potential difference develops across these two ends of this resistor. Now to know this, I have to connect the potential difference. I have to connect the voltmeter. To measure the potential difference across this resistor, I have to connect I have to connect the voltmeter. Now again, to connect the voltmeter should be connected in parallel. So suppose the voltmeter should be connected this way. One terminal of the voltmeter should be connected to this end of the resistor. Another terminal of the voltmeter should be connected to this end of the resistor. Now how to connect this voltmeter? The positive terminal of the battery should be connected to positive terminal of the battery. Positive terminal of the voltmeter. Positive terminal of the voltmeter. This is the positive terminal of the voltmeter. Positive terminal of the voltmeter should be connected to positive terminal of the battery. And the negative terminal of the voltmeter should be connected to negative terminal of the battery. So this way we connect. This is the series connections of a voltmeter, parallel connections of a voltmeter, parallel connections of a voltmeter. So now students, we know ammeter should be connected in series and voltmeter should be connected in parallel. Now student, let's take one more circuit to understand the proper connection of this voltmeter. Say suppose I have two resistors in this circuit. The current is flowing, certain amount of current is flowing through this circuit. I want to know how much potential difference is consumed by this resistor. Or say suppose I want to know how much potential difference is consumed by this, or potential difference develops across this resistors. Now to know how much of a potential difference develops across this resistors, I'll be connecting the voltmeter across the terminal. Say suppose this is the voltmeter. So plus and minus, plus the positive terminal of battery, a positive terminal of the voltmeter should be connected to positive terminal of the battery. And negative terminal of the voltmeter should be connected to negative terminal of the battery. If I want to know how much potential difference is consumed or how much potential difference develops across this resistor, I'll be connecting voltmeter across the end of this two resistor, making sure that positive terminal of the voltmeter is connected to positive terminal of the battery and negative terminal of the voltmeter is connected to negative terminal of the battery. So if voltmeter is connected here, it means this voltmeter measures the potential difference developed across this resistor. If I have connected the voltmeter across this resistor, it means this voltmeter is measuring the potential difference developed across this resistor, students. So student, I hope you understood how do we connect the potential difference and what care must be taken to properly connect the voltmeter and the ammeter in circuit.